Okay, here's a fun one. We're going to determine where this function is decreasing based off its derivative. And here the derivative is cosine x minus 2 cosine squared of x. So same thing as usual. We have to find its critical numbers. We're already given the derivative, so we need to figure out where the derivative is 0. So we're going to set cosine x minus 2 cosine squared x equal to 0. I'm going to factor out a common factor. 1 minus 2 cosine x. So you set each factor equal to 0 to solve it. So this one will be 2 cosine x equals 1 cosine x equals 1/2. So we have to solve these two trig functions, figure out where cosine is 0 and cosine is 1/2. So we're going to take the unit circle here. Cosine is 0 when x is 0. So x is 0 right here and right here. Pi over 2, 3 pi over 2. And then we have to figure out what cosine is 1/2. Again, cosine is x. So here's about where x is 1/2. So we're on this spoke and this spoke. And I'm just going to kind of fill out my other spokes for counting purposes. But this is pi over 6, 2 pi over 6. 3, 4, 5, 6, 7, 8, 9, 10 pi over 6. So our critical numbers in order are pi over 3, pi over 2, 3 pi over 2, and 5 pi over 3. And that's from 0 to 2 pi. So now it comes time to set up my chart. It's going to be a big chart because we have a lot of critical numbers. I'm not going to bother putting my, that's a 3 here. I'm not going to bother putting my intervals here. We're pretty good with that, I think. Like this is pi over 3 to pi over 2, etc. But I do want to remind you, starting at 0, ending at 2 pi. 0 and 2 pi are not critical numbers, so you may use them in your tests. And I prefer to use them when they're not actual critical numbers. So my tests are going to be this. In this interval, I'm going to test 0. In this interval, now we're between, this is going to be an issue here, a big issue. So, this is going to be something between pi over 3 and pi over 2. We'll come back to that. In the next interval, that's easy, we'll just use pi. The next interval, we have the same issue as the previous one, finding something between 3 pi over 2 and 5 pi over 6. And then the last interval, we're going to do f prime of 2 pi, and that's going to be easy because it's the same as f prime of 0. So these two intervals I'm going to get back to because those are going to take some explanation. Let's start with f prime of 0. f prime of 0, if you plug 0 into the derivative, and I'm going to use the factor form, you get cosine of 0, which is 1, so it's the positive, times 1 minus 2, which is negative. So we have decreasing there. Pi. Cosine of pi is negative 1. So we have a negative 1, and 1 minus 2 times a negative 1 is 1 plus 2. So we have a negative 1 times a positive. Negative times a positive is a negative. And in this interval, bam, same thing as this. So let's go back here. We need to figure out what the derivative is right here. Now, cosine is x. So this is what we want to think of. Cosine of this angle is positive because x is positive. So here's what I'm thinking right now, without even mentioning what this angle is. I'm just using my unit circle. Cosine of this angle is positive because it's x. 1 minus 2 cosine of this angle. Now, this is very, very close to 0. Look at where it is on the x-axis. So we can say it's like 0.001. That's where it is on the x-axis. That's what cosine is. So it would be like 1 minus 0.002, which is positive. Now, I'm glad this was a video. I'd hate to give this to you. Well, you could handle it, but it's something you have to think of. You won't be tested on one just like this, but I want you to understand it. Now, if you look at this one, watch this. That's where this angle is. And we're plugging this angle into cosine. Well, that's going to be the exact same as this because they all translate to this point right here. You can think of it as positive 0.0001. So nothing's going to change here. Now, if you really, really, really didn't understand it, you could plug this into your calculator. Find something between pi over 3 and pi over 2, make it a decimal. But it's nice to think about it that way and use the unit circle. So anyhow, we have to answer the question. Where is the function decreasing? Well, that would be wherever the derivative is negative. So it's decreasing on 0 to pi over 3, along with pi over 2 to 3 pi over 2, and also 5 pi over 3, comma 2 pi. You can well, I hope that's it. I hope you enjoyed watching that as much as I enjoyed doing it. So have fun.